Good morning, everybody. Good to see you all. So today we will continue our discussion on the K-map specifically, and we'll move on to more complicated versions of K-maps. I hope you were able to at least get the basic idea of how to convert a truth table into a K-map format, right? Can we safely say that we at least understand the basic? But now we will see other caveats and other variants of K-maps and see how they can be very powerful. So very quick recap, given a truth table, you can map it into a K-map with certain rules. Obviously, depending on whether you have two variables or three variables, the K-maps look different. But we use a strategy so that between two neighboring cells, one variable, just one of the variables will change. For example, across the row or along the column, you just have one bit change. Even if you have like two variables, for example, here BC, you organize the combinations in a way that just one variable change occurs between two adjacent neighbors. Okay, and then this is where we stopped, I think, in the last class. So basically, we try to incorporate a Boolean function, a given Boolean function, into a K-map. And that's when we stopped. I received a few questions after the class, so I will address them for everybody here. You must have noticed that one of the ones was not covered. This is taken from textbook as a screenshot. They basically meant to show how this function could be converted into K-map. They didn't really pay much attention to covering all the ones. They didn't even try to get a K-map optimization out of it. But that's a good catch. Obviously, make sure when we try to group these ones together, we will have to make sure we cover all of them. We cannot leave out any ones, right? Does that make sense, folks? So that was a good catch. We have to make sure that this is also covered. But now, having said that, what I didn't get a chance to get into in the last class was what is the optimized variant of this function? Now that you have converted this function into this format, can we somehow optimize it a little bit more, right? Using the K-map approach. So let's do it together. And in doing so, I will also highlight one key factor about grouping these ones. Remember, you can only group a specific number of ones, and that specific number would be any power of 2. That means you could take just one. Why? Because 2 power 0 is 1. That's also allowed. But you're not going to get any optimization out of it, honestly. If you take all of these ones separately without grouping them, the more you group, the more optimized you get, by the way. All right? So that defeats the purpose of getting into K-map anyways. So if possible, we would definitely make sure that we group them together. Okay, the other option would be to group 2 power 1, meaning 2 of the ones together. That's exactly what we're doing here. 2, 2. What is the next option? 2 power 2, which is 4. So we could also group 4 ones together. An example is here, and we'll see some other examples, by the way. Are you all with me so far, folks? Remember, you can group them horizontally and vertically, but you cannot do something like this. Let me show you. You cannot do like this. This is not one block, but you can do it in two separate. So this is one group, this is another group, that's fine. There can be an overlap, but there will be two groups. It cannot be just one single group where all the ones are, kind of close to each other. No. One other thing that you cannot do is you cannot use any diagonal grouping like this. You haven't seen that yet, but we'll see something like that. So you cannot group them diagonally, only horizontal and vertical. What is the other rule? You cannot have any other grouping except for the number that represents any power of 2. For example, I cannot group the 3 ones together because that doesn't represent a power of 2. Are you all with me? So if there were, imagine there was no 1 here, just 3 of them. I couldn't have grouped all 3 of them together. I would have used, let me show you. Imagine this was a 0. Then I will have to use this as a group, this another group, and this is another group. Are you all with me? Okay. So, and don't worry, we'll do enough practice that it will gradually become easier for us to understand. So let's first take a moment to get a function out of this thing. Okay, first, I want to cover this huge chunk of ones, like 4 of them, which is great. The more you can group together, the more better optimization you'll get out of it. Okay. So here you should look for the variable that doesn't change. What is the variable here that doesn't change? A. And A, like if you have 0, you have to prime it. If you have 1, you don't have to prime it. You just take the variable as is. So since this represents 0, I should use A prime. And by the way, folks, also take a notice. Don't just look at one variable, also look at the other variables in the other side, because they are all involved in making these ones. Okay, I know that these variables will change. When you have 4 cells, these variables will definitely change. For example, here, B didn't change, but eventually it changed. Similarly, at some point, between these 2 neighbors, C didn't change, but if you go to 4 neighbors, then at some point they will change. But for a moment, just consider this. Imagine we had only these 2. Only these 2. Then you have to see that A doesn't change and also B doesn't change. Can you see that, folks? B stays 0 for both of the cells. In that case, I will have to take A as well as B. So it would have been A prime, B prime. And I'll show you examples like that. Don't worry. But for this particular example, A doesn't change for these 4 ones, but any other variables will change at some point. So I don't take them at all. So what I do is I take A prime for this particular row. So I've covered this one with A prime. Let's do the next one. What is left? This one's left. So for this one, let's take a notice as to which variables don't change. Do you think variable A changes between these 2? Yes, it does. You switch from 0 to 1. So I don't care about that. But notice BC doesn't change. For both of these ones, BC remains the same. Are you all with me? So I take BC, but I take it in a way that for 0, I prime the variable. For 1, I don't prime the variable. So for B, I have to use B prime and C, and then plus. So this is the optimized function. Okay, are you all with me? I mean, we could have done it with some theorems that we have seen in the past as well in this course. That's fine too, but with K-map, it's like straightforward. You don't have to worry about any theorems or anything, just the rules that K-maps tell you. All right. Okay, don't worry. Let's not get stuck in this one. We have many other examples coming up. So you will have enough practice, and we'll quickly move over to 4 variables and even finally 5 variables as well. So if you understand 4 and 5 variables, all of these will be like nothing. Okay. Yes. Oh yeah, yeah. Sorry, I didn't finish that. See, if you don't group them, you don't remember. Thank you for pointing it out. So that's why it's important to make sure we group everything. Thank you, thank you. So for this one, notice what doesn't change. This variable doesn't change. And what is that? B, because it has 1 and C prime. So B, C prime. Thank you so much. Great catch. All right. Okay. Are you all with me so far? Just, one side note, and we have been lucky to get it here. In many scenarios with Boolean functions, you will end up with a situation where you have A B prime plus A prime B. This essentially represents A XOR B. Okay, so in some situations, you will see they will represent that as A prime plus B XOR C. It's all the same. You don't have to do it. You could just keep it as is. But in case you ever see it, don't feel like, oh, how did they get it? Because AB prime plus A prime B, that basically represents XOR. Make sense, folks? All right. Yes, just a side note. That's all. Okay, so that covers the function. So you didn't, I mean, if you're wondering, hey, did we get any kind of optimization out of this K-map? Can anybody compare this function with the one we started with? Can you see that? What do you see? We managed to drop one variable, like in one of the terms. So I managed to get from a 3-input AND gate to a 2-input AND gate. That's all. It's fine. It's not much. Like I said, the bigger the function is, more optimization you can manage. The smaller the function, it's probably already very optimized. Okay? Yes? Yeah. Yes. Enter column. Yeah. Yeah. Of course. Of course. That's a great question. That's a great question, folks. Uh, Let me repeat the question here. Okay. So you must have noticed that we had a prime, and that corresponded to this entire column, right? You must have seen how did you get this? We were just looking for the variable that didn't change, and the only variable that didn't change was a, and there was a zero corresponding to it, so we got a prime. Okay. Now the question is, how did I know that I have to group a somewhere and b somewhere else and c somewhere else? What if I did this? Imagine I could have done b here and ac here. Doesn't matter. I told you can do it. Okay. And then you may have gotten a completely different function. We don't know. We'll have to see. But that doesn't matter. Did I tell you that a Boolean function can have many equivalent? As long as the total. So imagine, I'm just making it up. So don't take it too seriously. All right. Imagine if I had C prime A plus A plus B prime. I mean, in terms of cost, wouldn't that be exactly the same? In terms of cost, but in terms of expression, it looks different. But in terms of cost, it doesn't change at all. So if you distribute your variables in a different way, instead of A, B, C, if you do B, A, C or C, A, B, you might get a different type of format, but you'll always get the optimized solution. Does that answer your question? It's a great question. All right. Any other questions? All right. Keep asking questions. That's how we learn. All right. That's how we make sure we understand this together. All right. More examples as the slide suggests. All right. So this is another truth table. And we are now kind of spoiling you by giving you the truth table. Gradually, we will move to examples where the truth table will not be given. We'll have to come up with it. And in fact, we'll see a 4-input case where we have 16 combinations, but I'll not give you the truth table, but we'll be able to do it. All right. Let's do it first for this one. So let's identify the ones here. 1, 1, 1, 1, 1. There are 5 ones. All right. If I were you, I would have just gone for zeros first. I would have looked at 3 zeros and put them there and then populate the rest with 1. Should we do it? Let's do it. All right. So, I mean, just to be, there are like 8 combinations in total. 5 of them are 1. So 3 of them will be 0. Which one is easier, to track zeros or track 1? Track zeros. So obviously, I'm going to track zeros first. Let's track the zeros. And typically, and without any loss of generality, I've chosen to distribute A across this direction and BC across the other direction. And honestly, it doesn't matter, how you distribute it. Make sense? So for A, 2 combinations will be 0 and 1. For BC, the combinations will be 0, 0, 0, 1. What's next? Thank you. 1, 1. Because you can only change one variable at a time. And then 1, 0. Okay. Now, let's distribute the zeros. This 0 belongs to the combination 0, 0, 0. Where is 0, 0, 0? You have 0 here and 0, 0 here. So you have a 0 at this location. Okay. How about the next 0? You have 0, 1, 1. So you have 0 here and 1, 1 is right here. So there is another 0. All right. Finally, this is the other 0, 1, 0, 0. So A should be 1 and you need 0, 0. So this guy is going to be 0. Notice that? So you covered all the zeros. So obviously all the other cells will have 1. That's how you can quickly do it. Okay. Oftentimes, like when you do K-map, we don't even show the zeros if you don't want to, but it doesn't matter really. Okay. Now we are not really after zeros. We're really after the ones. All right. So let's try to group them together. And I'm going to show you 2 examples of how you can do grouping in different ways. All right. First, I mean, tell me something. Can I do this grouping? No. Why? 3 is not a power of 2. So I have to stick to either 4 or 2. So let's do that. And remember, I cannot leave any one out. I have to cover all of the ones, right? So let's do it this way. Let's first group this one and this one. And I have 1 left. Maybe I can group it this way, like just by itself. I don't want to, okay. I don't want to put it in with anybody else, just by itself. Let's see what happens. All right, let's do it. So for this one, oh, folks, I erased this 0, 0, 0, 1, 1, 1, 1, 0. and 0 and 1. Let's do it. All right. So for this particular circle, which variable, what are the variables that don't change? Can you tell me, anybody? BC don't change, right? A changes from 0 to 1. So forget A. BC, B should be prime because the corresponding digit is 0, right? So I should have B prime C. And what is this one? Still BC doesn't change, but for this one, I have B C prime because it's 1, 0. Are you all with me? Okay. And finally, if I try to get this one separately, what variable doesn't change here? BC and also A. You see that? For a given one, all three of the variables don't change. Okay, so I will get ABC. ABC. Now, for a second, this is what you get, all right? I don't know whether it's optimized or not because we don't have that much experience, but we'll gradually get more experienced here. How about I group this one with another one and come up with a pair instead of keeping it separate, okay? And I told you, you can have a given one appearing in multiple circles. That doesn't matter, okay? So let's do it. Let's now group this one with maybe this one. Are you still with me? Okay, what changes? The other two will not change. So B prime C plus BC prime corresponding to these two circles don't change. The only thing that will change will be what happens to this one now. Folks, tell me what doesn't change here. A doesn't change, but is that the only variable that doesn't change? There is, just notice, there is also C that doesn't change between these 2 points. So I should do AC because the corresponding digit is 1 here. For C as well, it's 1. So AC. So this is the option that you end up with. Is it better than the one that you got before by keeping the one separate? Yes, but for sure, because you are getting rid of a 3-input AND gate and using a 2-input AND gate. All right, which is better. So which tells you never leave a 1 by itself if you can somehow bring it into a pair. Am I making sense? So if you can somehow bring it into a pair, although, yeah, I've already used this one, that's fine. Just to help out the other one, bring it to a pair. Now, the question is, does it matter which pair I go with? Say, for example, if I pair it this way versus pair it this way, does it change anything? It changes the functional representation. For example, the one that we came up with was this one. If you had gone with the other circle, you would have gotten a little bit different output. But in terms of optimization, in terms of the total cost, in terms of hardware, it will not change. But the expression will change. So in your practice or exam or quizzes or whatever, if you pick one versus the other, the function will change, but we don't care. Are you all with me? Okay. So as I told you before, the functions may look or appear different, but the overall output will be the same. Okay, and I want to highlight this one. Notice. What is MSOP? SOP stands for sum of product. So this format is called sum of product, right? Sum of products. What does M represent? We discussed this in the last class, minimum. This is the minimum sum of product. And remember the one that we got before, like B prime C plus BC prime plus ABC by keeping the one separate. Was that MSOP? No, it was not minimum SOP. It was just a SOP, not minimum. Are you all with me? Okay. Now, finally, one other thing, in case you had questions about, hey, if I do this and this pairing, and then I just get overboard. I just do both. Like I pair it this way, and I also pair it with the other one. Can I do that? You can. You will end up with a situation like this, where you have both terms. This is functionally equivalent. Your functionality will not change. As long as the Boolean function goes, it's going to be the same, but it will not be optimized, as you can imagine. So don't repeat unless you want to. The moment you cover all the ones, at least once, you are done. You have covered the function. But if you repeat, then you no longer have the optimized or minimum. Does that answer questions? Preempt questions, actually. In case at some point you, oh, can I do both? You can, but you shouldn't. All right. All right. Now, another example, moving to the next slide. Just wanted to show you, this is exactly the same K-map. If you look at it, the distribution of one is exactly the same, but you can group them in different ways. And you might end up with the exact same type of optimization with different Boolean function. So that's what I keep repeating, right? So because you don't know how to group them. So this is one way. Just notice these two K-maps. Don't you see that the distribution of one is basically exactly the same, right? But you can group them this way. 2, 2, 2. So you cover all of them. Or you can group them in a different way, which gives us one more new information, which I didn't discuss before, which I will do it now. All right. And you can group them like this or this. But how about the other one? Remember, a very big point to keep in mind is that K-maps wrap around in both direction, meaning this as if it goes like this. You see my point? It's kind of like a fabric that wraps around. So this column and this column are practically, I mean, it doesn't really do much for a 2-column situation because they are anyways neighbors, right? But imagine if you had 4 columns, then the 4th column and the 1st column, they are also neighbors, although they don't look like. Am I making sense at all? I mean, it doesn't look much for a 2-column case because they are anyways neighbors. But if you had like 4 columns, then it doesn't look like that 4th column and the 1st column are neighbors, but they will be neighbor because of the wraparound property. All right. How about the other one? How about the rows? The rows are exactly the same. For example, this is the 1st row. This is the 4th row. So imagine they basically just wrap around. So the 1st row is adjacent to the 4th row as well. So you can group them this way. I told you, you can group neighboring ones. So this one and the other one, they are also neighbors. Like I said, this is 4th row, this is 1st row. If it wraps around, they're practically neighbors. So you can group the ones that way as well. Does that make sense, folks? All right. So for this particular situation, you actually didn't have to make it that complex, but we deliberately showed you that you can do it. All right. And I'll show you how to get the function out of it. Okay. Give me a second. So basically, as if you're wrapping it around like this. Like consider a paper and you're wrapping it around. Okay. Now, okay. How do you get the function? Let me just do this one. For this pair, which variable don't change? Quickly, folks. A changes, right? Of course. So I don't care about A. What doesn't change or what do not change are B and C. So what should be my functional output here? B prime C, because B has 0, C has 1. Okay. So, and when I try to cover the next one, this one, tell me which variable doesn't change. A doesn't change, and thank you for noticing that. It's not just A. Also look at the values for the column. Notice B also doesn't change. So your A doesn't change, and the corresponding value of A was 1, and B doesn't change, and the value of B is 1. So you have AB plus. Okay, so you have covered these two. How about this wraparound case? Can you tell me which variable doesn't change for this? A doesn't change, but the corresponding digit is 0. So it should be A prime. And also, there is another variable that doesn't change here. C. For both cases, it's 0. So I should use prime, A prime, C prime. Does that make sense? It will make more sense as you keep practicing. No worries. So you can try doing it by yourself without looking at the answer at home. And if for some reason it doesn't make sense, come talk to me. Okay. All right. So that means you could group in different ways. As long as you're correct, as long as you don't repeat the same thing over and over again, you're going to end up with the optimized solution. Your solution may not look exactly like your friends, but it's fine. Okay, more example. Can anybody tell me what's unique about this example? Why did I choose to show this one? There are two things that are new. First, I mean, relatively new. I've already discussed the wraparound property, but this thing takes it to the next level. Yes, you're wrapping things around from the top and bottom, right? But more importantly, for the first time ever, you are seeing how 4 ones could be grouped, not in a column, but side by side. Does that make sense? Imagine for a second, if you had 4 ones like this, 1, 1, 1, 1. I could have grouped them this way. This is allowed. You don't have to necessarily just group them vertically or horizontally. Are you all good? And by the way, that's exactly what we're doing, except it's a little bit difficult to understand because we are wrapping around the first one with the last one because they're neighbors. So, but still, yes. As long as the total number of ones is a power of 2. That's what you can do. Okay, sure. All right. Are you all with me so far? Okay, let's make the function out of it first, okay? And then we'll do something else. So this is tricky because there are 4 ones and we have to work together to make sure we get the proper function. So please pay attention. This is the first time we're doing it. So my function, let's start with the 4 1 block. 4 1 block, this one. Okay, can you tell me, let's take one variable at a time. Do you think A changes between these 4 ones or no? A changes. So let's just toss it. We don't care about A. Do you think B changes between these 4 variables? You can see that it changes. Yes, let's toss B. Do you think C changes between these 4 variables? No. C is the only variable doesn't change. What is the corresponding digit? Is it 0 or 1? 0. So I should prime it. Excuse me. I should prime it, right? So C prime. So I arrive at C prime corresponding to these 4 ones. Excuse me. I'll make a comment in a second, but let's cover the other remaining block. So this is the other remaining block. Tell me which variable doesn't change? A doesn't change. And also B doesn't change. Notice, don't forget that, right? So corresponding to A and B, you have 1. So you should be getting AB. Done. Simple. Did you see when you group more variables together, the expression becomes even simpler, right? So the more you group, the simpler the outcome becomes. That's the beauty of K-map. So it makes sense to use K-map when the function is like super complicated, many ones distributed across the domain. So the higher number of variables, 4 or 5 input variables, will make K-map even more powerful. Like when it has like 2 variables, when it has 2 variables, it doesn't really make any sense. 3 variables, still, I mean, we're reluctant to do it. But when you have 4 and 5 variables, for sure, I mean, it's difficult to do a manual algebraic simplification. How are you doing? Okay? Okay, all right. Stop me if you have questions. All right, so that concludes this lecture, but we have more coming in. So let's, while we are fresh with this practice, let's move to the next one. Continued, K-map continued, right? So now we will start looking at what if I don't give you the truth table? Okay, how can you first create a K-map and then optimize it, right? First question, this is a function. How many inputs? 3 inputs. You can see it in both ways. It's given, or if it is not given, you can see how many literals you have. You have A, B, C, or they're prime. So you have like 3 different kinds of literals, right? A, B, C. Fine. So you have 3 variables. Now, the question is, can any minterms be combined? Well, what this question really means is, can you combine any ones? Because there are situations where you may not be able to combine ones. You know why? Let me show you one example before I move over to the example that's at hand. Let me show you without ABC or anything. 1, 1, 1. Okay, if I give you a K-map like this, can you combine any ones here? No. So what do you have to do, folks? Tell me. Take this one, like spell it out. Take the other one, spell it out. take the other one, spell it out. So you will not get any optimization out of it, which really shows the function that was given was already fully optimized. Make sense? So K-map is basically a waste of time then. But you don't know unless you map it, and then you say, oh, okay, doesn't make sense. So you have to map it first to understand that, oh, it doesn't change anything. Anyways, sorry. So let's do it together. You have three variables. Before I do anything, let me just draw the K-map first. And without any loss of generality, I'm going to do A here and BC here. So that gives you 0, 1 and 0, 0, 0, 1, 1, 1, 1, 0. Are you all good? Okay, now we're going to see how to put these terms individually into these boxes. So for each of these min terms, these are min terms, obviously, you have a corresponding one. So A represents 1, B prime represents 0, C prime represents 0. So 1, 0, 0. You should have a 1 at this location. 1, 0, 0. Can anybody help me find 1, 0, 0? So this is 1, this is 0, 0. So this is my location. Let's do the second one. A, B prime, C. Corresponding to A, you should have 1. For B prime, you should have 0. For C, you should have 1. So 1, 0, 1. For 1, 0, 1, I should have 1. 1. So where is 1, 0, 1? This is 1. This is my 0, 1. So this is 1, 0, 1. Are you good? Okay. Third one, ABC. For A, I should have 1. For B, I should have 1. For C prime, I should have 0. So 1, 1, 0. This is 1. Where is 1, 0? This is 1, 0. 1, 1, 0 is this one. Excuse me. Finally, ABC. For ABC, I'm looking at 1, 1, 1. So where is 1, 1, 1? 1, 1, 1. This is 1, 1, 1. Are you all good? Okay, it looks really interesting and simple because like 4 ones lining up right away. All right, and all the others will be 0. I don't even need to fill them. So if I take all 4 of these ones together, I can easily come up with an optimized solution. And tell me quickly, which variable doesn't change here? A. So my function should be A because all the other variables will change at some point, right? And that's it. Like super simple. Don't you think? It's super simple. All right. So how many variables are eliminated due to grouping? You basically eliminated 2 variables. B and C are not even in the picture anymore. You just have like, that's how powerful it can be eventually. Okay, let's move to a different example. Now it's more verbose, like it's giving you a description of the function, not even a function itself. And now you're gonna, we are practicing for all kind of scenarios. If you're given a truth table, sure, we can make a K-map. If you're given a function, sure, we can map it into a K-map. If you're given a description, let's see if we can make a K-map out of it, all right? Let's do it. A 2-to-1 multiplexer, or MUX in short, which you are working on for your lab, I hope, uses 1-bit select input S to force the output go to follow one of the 2 inputs A and B. You already know this, right? It connects an input to output G. Find the minimum sum of product, which basically means the optimized version, right? Minimum sum of product is the optimized version for a MUX. So we'll have to come up with the truth table. So for a MUX like this, you have a select signal and you have 2 inputs, A and B. And depending on what the select signal is, if it is 0, you select A and put it to the output. If it is 1, you select B and put it to the output. That's all, right? So how many inputs do you have? A, B, and there is one other. S. Select signal itself is a input. So I should create a truth table with 3 inputs and 1 output. So maybe S, A, B, and this is my output G. So I'm creating the truth table myself. Since there are like 3 inputs, so 8 combinations. 1, 2, 3, 4, 5, 6, 7, 8. So I should just do this 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So that's 8 combination. I'm just doing it blindly, right? These are always the universal 8 combinations. Done. Now, I should look for how my function should look like based on the description. Okay, I just told you when your select signal is 0, which is the case here, your output should follow which input, folks? A. And when the select signal is 1, your output should follow B. What do you mean by follow? Basically, whatever is in A will be sent to output. Whatever is in B will be sent to output. Okay. So when your select signal is 0, I should follow A and send it to the output. That means the output should be 0, 0, 1, 1. Whatever A is, your output will be exactly the same. Does that make sense to you, folks? Or no? Okay. So when the select signal is 1, who should I listen to now? A or B? Go ahead. B. So whatever is there in B, which is 0, 1, 0, 1, should go to output. So you have a complete truth table now. All with me? Make sense? Okay. I can also give you the truth table, or I can make you prepare the truth table from simple logic, which we have just done. Okay. Now, once you have the truth table, is it any different versus the other things that we practice with? So let's just do it anyways. So there are 3 variables, S and AB. So I'm gonna do this. S, AB. So there are gonna be 4 combinations here: 0, 0, 0, 1, 1, 1, 1, 0. And for S, I'll have 0 or 1. And I'm gonna put the ones here first, because there are 4 ones and 4 zeros. So it doesn't matter which one I do. So let's do it one more time quickly, right? Please give your inputs. So this is the first one. What is the combination? 0, 1, 0 for the first one. So 0, and where is 1, 0? This is 1, 0. 0, 1, 0. This is where I have my first one. For the second one, what is the combination? 0, 1, 1. So I have 0 here and 1, 1 right here. So this is my second one. What is the third one? This is the third one. The combination is 1, 0, 1. Are you guys all with me? Okay. 1, 0, 1. So this is my third one. And the fourth one is 111, 111. So it should be 1 and 1, 1, which is this one. Okay. I can easily cover it with 2 circles. You can see that. So like this, 1 circle, second circle, done. You have covered all the ones. Super simple. So what is the function? What is the output for this first circle? Which variable doesn't change here, folks? S doesn't change. Is there anything else that doesn't change? Notice A doesn't change at all. So it should be, for S, I have 0. So it should be S prime and then A, because for A, I have 1. Plus, how about this one? Which variable doesn't change for this one? S again, it doesn't change. But there is one other variable that doesn't change here, folks. B doesn't change. Notice that the B doesn't change. So I should have S, B. Are you all with me? So this is the functional output of a mux. Okay, so we have found the most optimized version. Any questions so far? Okay, so let's move on to the next example. We are ready to look at 4 variable K-maps. So we're gradually getting more complicated scenarios. I mean, don't worry, none of these are honestly complicated. Just, they look bigger, that's all. Ready? We have to do it together. Don't give up. If you fall behind, stop me, I'll repeat it. I don't mind, honestly, spending time repeating. I'm not in a rush. Okay? So it is important for us to understand as a team. And absolutely, for some reason, you feel like really, really bad about asking again, please come talk to me during my office hours. So still don't let go. Like, don't let go, because these are critical and important. These are foundational concepts for digital electronics. If you let go at this point, you'll never like this field. Like, you'll feel like, oh, this is not for me. This is so boring. This is like, okay. So I don't want that to happen. So if possible, ask me now. I will repeat. If not, come talk to me during my office hours, or even out, just send me an email. We'll find time to talk to each other. All right. Now, this is a function with 4 variables. That immediately tells you the truth table will be longer. How many combinations with 4 variables? 2 raised to 4, which is 16. So 16 rows. Of course, lots of zeros and ones. And I don't really know the functional output. I'm going to see the functional output. For this example, I chose to show you a different functional representation, which is the sum of min term. Have we seen that before? Okay, it's exactly the same. It's telling you where the ones are. Where is my first one, folks? Position second, which is 0, 1, 2. So this is my first one. And the next one will be in the 5th position. So 0, 1, 2, 3, 4, 5. Make sense? So that's where my second one is. And then 7. If this is 5, this is 6, 7. That's where your other one is. And then 8. If this is 7, then this is 8. That's where your next one is. Then 10, 9 and 10. That's where your next one is. 12, 11, 12. That's where your next one is. 13, 13, next one. And 15. So it's like 14 and 15. That's where your next one is. Make sense? All good? Okay. So now that I have this truth table, I can easily map it into my K-map. But how will the K-map look like? Here is how it looks like. Remember, when we had 3 variables, we distributed 2 of them in one direction, the other one in the other direction. If you have 4, you will distribute 2 in one direction and the other 2 in the other direction. Make sense? You could take any combination of, if you have A, B, C, D, you can always do AB and CD, or AC and BD, doesn't matter. But is there any reason to do AC and BD? Really? You can do it, but it will make your life complicated, because when you're looking for 0, 0, 0, 0, I mean, it will be, or 0, 0, 1, 0, you should be mindful of AC represents this and this digit, right? It will be difficult for you to track. So if you do AB and CD, it's typically easier. These 2 will be AB, the other 2 will be CD, easier to track. So that's why you will see we always do them in series. We don't just randomly pick the variables together. Okay? Make sense? So for this particular example, we have 4 inputs. Let me do it this way. Okay, you have 4 inputs, W, X, Y, Z. So I do WX in one direction and YZ in the other. And notice the combinations are exactly the same. 0, 0, 0, 1, 1, 1, 1, 0. The same applies here as well. Previously, you just had 1 variable, so 0 and 1. So 2 rows. But now there are 2 variables marched together, 4 combinations, 4 rows. Make sense? All right. Now what I'm going to do is I take these ones and I'm going to map them right here. I will show you a couple of examples. Let's do maybe this one. Can you see this? What is the combination, corresponding combination? Tell me. 0, 1, 0, 1. So I should look for 0, 1 right here and the other 0, 1 right here. So this is the location. Let's take another randomly, maybe this one. What is the combination? 1, 1, 0, 1. So this is 1, 1 and this is 0, 1. So I have 1 here. Can I map the rest? Is it any different versus what we have done so far? No, just map all the other ones. And to save time, I just did it before. So that's how you distribute the ones. All right, now it's time for us to map. and cover all the ones. You guys ready for it? Okay, let's do it. The first thing that I see is, I mean, I'm tempted to take 4 right away. There you go. You have 4 ones. I like it. And then you have 2. And you have 2 more. You know how? Yes, wrap around this ones like this too. So I'll do the wrapping case first, because that's the least obvious. So let's do it first. My functional output would be, which variable do not change? Here, notice yz will not change. So yz will come, but for y you have 1, for z you have 0, so yz prime. Yes. And also, is there any other variable that doesn't change here, folks? Is it w or is it x? X. Do you see that? What is the corresponding digit? Is it 0 or 1? 0. So I should have x prime. So there you go. That's what you need to cover this wraparound case. Plus, I'm tempted to cover the square. Let's cover the square now, okay? So compare the row. Which variable doesn't change? Just first let's do the row, all right? So which variable doesn't change, folks? Notice z doesn't change between these 4 ones, right? So can I take z here? What is the corresponding digit? 1. So I have to take z, not the prime. How about the column? There is another variable which doesn't change. Because this x doesn't change. And what is the corresponding digit? 1. So I should write xz. Okay. What else? That's done, basically. That's the square. And the only thing left now is this one. Tell me which variable do not change for these two, for this combination. YZ do not change. And also W doesn't change. Notice that W stays the same. And W is 1 and YZ are 0. So Y prime, Z prime. That's your function. Isn't that pretty much the same as what we did for 2 input or 3 input variables? Right? So there you go. You have a practice. By the way, you can try doing it yourself. And I know the first, it might make sense in class, but when you try doing it at home, you might run into confusion. And that's exactly what we want. I want you to find that you're confused, because that's when you come back and learn, right? Hey, I didn't really get it. Okay, so we'll continue our examples. And this is just another example. I encourage you to try to do it at home, but otherwise anyways, we'll do it in class. All right. Thank you, everybody.